Slice. The slice data type is a slice of array data. Slices are similar to arrays. The difference is that the size of the slice can change. Slides and arrays are always connected, where slices are data that access some or all of the data in the array. Var, it's the keyword used in Go for variable declaration. In slice, it's the name of the variable, indicating that it's a slice of integers. Int, it specifies the type of the variable, indicating that it's a slice containing elements of the integer data type. Slice can be created using the built-in function make. When you use make, one option you have is to specify the length of the slice. Var, this keyword is used to declare variables in Go. Slice, this is the name given to the variable. Make, string, 10, 20. This part initializes the slice. The make function is used to create a slice, and it takes 3 arguments. String indicates that slice is a slice of strings. 10 represents the initial length of the slice. It starts with a length of 10. 20 represents the capacity of the slice. The capacity is the maximum number of elements the slice can hold without reallocation. The following is a useful slice table to help create data type slices. Slice function table, which can also be useful to help use slices. We have created a variable named slice in Go, which is initialized as a slice of strings containing the values USA, UK, and JAPA, ANGN. Following the initialization, a print statement has been employed to display the contents of the slice variable. This concise piece of code captures the essence of creating and displaying a string slice in Go. By declaring the slice and assigning specific string values, we gain the ability to easily manipulate and showcase the contents of the slice. The subsequent print operation allows us to observe the outcome, verifying the successful creation and initialization of the string slice. In Go, the creation of slices can also be accomplished using the make function, allowing for the specification of both length and capacity. In this instance, a slice is created with a length of 10 and a capacity of 20 using the make function. Subsequently, a print statement is employed to display the resulting slice. This approach with the make function is particularly useful when there is a need to explicitly set the initial length and capacity of a slice. The length determines the number of elements initially present in the slice, while the capacity defines the total space allocated for potential future elements. The print operation provides a means to examine the slice and confirm its dimensions. Continuing with our exploration, we proceed to access specific elements within a slice using array indices in Go. This approach allows us to retrieve individual items based on their positions in the slice. Subsequently, we employ a print statement to visually inspect and observe the outcome of the slice access. The process of accessing slice elements through array indices underscores the versatility of Go's syntax, providing a straightforward means to interact with and retrieve precise data from slices. Array indexing enables developers to pinpoint and extract specific values from the slice, facilitating nuanced data manipulation. In Go, the addition or expansion of a slice can be accomplished using the append function. This dynamic operation allows for the seamless inclusion of new elements into an existing slice. Following the append operation, a print statement is executed to display the resulting slice. The use of the append function showcases the flexibility and adaptability inherent in Go's slice management. It provides a convenient way to extend a slice with additional elements, accommodating changes in data requirements during runtime. Now it's time for us to print to see the results. As you can see, The German data has been entered into the slice. Furthermore, we can perform the action of copying a slice in Go by utilizing the copy function. This operation involves duplicating the content of one slice into another. Following the application of the copy function, we proceed to execute the program, initiating the copy process. Now it's time for us to print to see the results. Exercises. Number 1. Declare a slice named numbers with integer values 1 to 5. Print the slice. Number 2. Declare a slice named colors with string values representing colors. Append a new color to the slice and print the updated slice. To address the first task, we initiate the process by declaring a slice named numbers in Go. This slice is initialized with values ranging from 1 to 5, providing a sequential series of integers. Following the declaration and initialization, a print statement is executed to display the content of the numbers slice. To address the second task, we proceed by creating a slice named colors in Go, initialized with the values red, green, blue, and yellow. Following the initialization, we add the color purple to the slice. Subsequently, we execute a print statement to observe the contents of the colors slice.